Well, thank you for joining us once again for the Robin Baird Marathon. I am so excited that Robin has been here the past 2 days and given a few talks. This is talk number 3, and really excited to hear about this spinner dolphin tagging project he's been working on. But I will give you once again a brief introduction, not that he needs one, but going to say it anyway. So Dr. Robin Baird is a research biologist and the Hawaii Program Director for Cascadia Research Collective, a nonprofit research and education organization. He has been studying cetaceans since 1985 and received his PhD from Simon Fraser University in 1994, with his thesis focused on foraging behavior of mammal-eating killer whales. While based in Olympia, Washington for the last 27 years, his research has primarily focused on Hawaiian dolphins and whales. He is also a member of the Pacific Scientific Review Group, an advisory body for NOAA fisheries, the research alternate member of the Sanctuary Advisory Council for the Hawaiian Islands Humpback Whale National Marine Sanctuary, and a conservation primary member of the Sanctuary Advisory Council for the Papahanaumokuakea National Marine Sanctuary. So with that, I will turn it over to Robin.
Thank you, Renee. Renee just really wanted another opportunity to practice saying Papahanaumokuakea. So did a good job. You're getting better over time. So practice. I was thinking this may actually be the first time I've ever given a talk on spinner dolphins, even though I did some work with spinner dolphins when first starting working in Hawaii in 1999. But before I get started in sort of the genesis of this project, really it was Michael Moore at Woods Hole and Randy Wells at the Sarasota Dolphin Research Program that wanted to develop a way of remotely deploying tags on small odontocetes that would minimize damage to the animals in terms of damage to the dorsal fin, minimize risk to the individuals. So they, with some engineering help from folks at Woods Hole, developed this new tagging system called the TADpole, which deploys a single pin fin mount tag. I've got one of the tags here we can pass around onto the dorsal fin of bow riding dolphins. And the development of this tool was funded by Dolphin Quest, and our particular field project in June of this year was also funded by Dolphin Quest. And I was involved in one of the first field trials with this system in 2018, where basically things didn't work, not surprisingly, the first time you tried to use it in the field. And the engineers went back to the drawing board and came up with some improvements to the device. And subsequently, Randy and Aaron Barleycorn at Sarasota Dolphin Research Program had used this particular system to deploy these types of tags on Atlantic spotted dolphins. I also want to acknowledge a lot of volunteers that we had that participated in our June field effort. We've been getting follow-up photos of our tag dolphins from several tour operators that operate off the west side of Oahu, as well as other individuals. Thank Danny Barrios, who prepared all the animations, which are really cool, you're going to be seeing soon, and Michaela for help with location data processing. Now, a little bit of background. Spinner dolphins were actually first radio tagged back in 1971 by Ken Norris, and this shows the track of one individual just over just more than a day-long period off the northwest side of Hawaii Island, north end of Kona. And it was a VHF tag, quite a large, bulky tag in 1971. That particular tag didn't stay on very long, and just from VHF tracking, it's difficult to track, particularly at night, to get these locations. Randy Wells, in later that same decade, 79 and 80, along with Ken Norris and Barrett Wursig, VHF radio tagged 3 additional spinner dolphins off the Kona coast and tracked them for relatively short periods of time. Now, between the 70s and the 90s, there was no tagging of spinner dolphins. When I first started working in Hawaii in 1999, we used a suction cup tag that I had been using with killer whales and other species And this is, as it says, not a spinner dolphin. This is one of the suction cup tags on a pantropical spotted dolphin. But we did have several tagging attempts with spinner dolphins, and they did that spinning thing, and the tags came off very quickly. So we concluded that the magnitude of the reaction of spinner dolphins to tagging, it's not really a feasible method for using suction cup tags. We started our limpet tagging in Hawaii in 2006, and we never included spinner dolphins in any of our permit applications just because of the size of the animal and the potential risk to the animal of using a more invasive tag. So it wasn't until the development of this tadpole system that this methodology for spinner dolphins was really possible. Now, there's a lot of reasons to tag spinner dolphins. Spinner dolphins are one species that probably receives the most attention from swimmers and tour operators in Hawaii. There's been a number of studies, in particular the one by Julian Tyne, which estimated that off Kona, spinner dolphins were exposed to human activities for 82% of their time within 100 meters during daylight hours. Spinner dolphins rest in nearshore waters during the day and then move offshore. So all of this exposure to human activity was during their primary rest periods. And because of that nearshore resting behavior, they're really more vulnerable to easy access from swimmers from shore. Boaters can move offshore, but they're the only species that swimmers from shore could regularly get to in Hawaii. A couple years ago, National Marine Fisheries Service put in a 50-yard approach rule and a no swim rule with spinner dolphins. This drone footage was taken shortly after that rule went into effect. A study from Colorado State University, and they basically found that there was very little compliance with the regulations that went into effect. So even today, even though those rules exist, there's very little enforcement, and particularly from swimmers from shore, very little understanding or compliance. Although tour boats in general, I think, have done a really good job at meeting and acknowledging the approach rules for spinner dolphins. Now, I mentioned this tadpole tagging system. This is a breakdown of the system. The main purpose or the main value of this is that it basically takes a core through the dorsal fin and then inserts a pin that attaches that tag simultaneously. Because it's taking a core, it reduces tissue damage. When you think of limpet tags, they're actually displacing the tissue and causing pressure necrosis, and then the backward-facing tines on those darts are causing damage to the tissue around them. They're meant to attach. But anyway, so reducing the tissue damage has its tissue trauma has its own value in terms of welfare, but it also increases the attachment duration of these tags. And the other thing about these particular, this system is that the only place it can deploy a tag is onto the dorsal fin of the animal. The way it's designed, there's a little pressure plate in the back of the tool. These are guides. This is looking at it from the side, but it would be held differently. And the tag, the dorsal fin of the animal has to come into that guide and touch that pressure plate for this pneumatic projector here to basically apply the tag. And we went to Hawaii with the hopes of being able to, we went to Hawaii with 14 of these fin mount tags with the hope to be able to deploy 9 of them on spinner dolphins and use the other tags for other species if we had the opportunity, bottlenose dolphins and pantropical spotted dolphins. And at the time, what my hope was to try to get 3 tags in each of 3 different groups of spinner dolphins so that we could also look at some of the dynamics of movements of individuals in different groups. 3 different types of fin mount tags. A spot tag, which is just an Argos location only tag that we had set to transmit 14 hours a day. A spot F, 2 spot F tags, which are a fast lock tag in addition to Argos. And the fast lock locations, as you probably know, are much more accurate than Argos locations. So for those, we had them set to try to acquire fast lock locations for 16 hours a day, and Argos only 8 hours a day. And then 2 splash tags, which are, in addition to Argos, are also recording diving behavior. And this shows the use of the tool on the front of the boat with bow riding dolphins. And I've got some videos that will will show both the types of behavior that we're trying to get the tags on, and then a couple deployments. As you can tell, this is very shallow water. A lot of the times, spinner dolphins in Hawaii are resting in, here it's probably just 2 meters, but 2, 3, 4, 5 meters of water. And a lot of it initially was trying to get a better idea of what are the circumstances to get the animals to bow ride in the position and the speed that would allow us to get the tag on. We experimented sometimes. Sometimes you can encourage them to bow ride by going a little bit faster. We did a little bit of that. We basically came to the conclusion that the best way to get the tags on were probably just to match their speed as precisely as possible. And then when they come up to surface, have an opportunity to tag. So there was a successful tagging. I'll show that one again. And I'll show you a different tagging, this time in slow motion. So here you can see the antenna on the tag. And the animal swims away with the tag. You can see a reaction here. Some of the other animals in the group, that splashing behavior. I'll show you that one more time, just because it's so cool. Now, at the beginning of this, we really had no idea whether or not how the animals were going to react. Spinner dolphins spin. Were they going to spin until the tags came off? Were the spinning reaction going to be so extensive that we were fully prepared to tag one and then stop tagging spinners depending on the reaction? And amazingly enough, the first animal we tagged did not spin. We had a fast dive. We followed the group. There was no spinning by that tagged individual. The second individual we tagged spun 5 times after tagging. The third one didn't spin at all. So of the 9 individuals we ended up tagging, 5 of the 9 showed spinning reactions. 4 of those 5 were just between 2 and 5 spins. And then the very last animal we tagged did have 15 spins over about a 40-minute period. Although what was interesting in that case is it didn't start spinning for the first 4 minutes after tagging, and then it would start spinning. The reason why spinner dolphins spin is primarily to get rid of remoras. So this spinning as a reaction isn't a surprise in any way, although I think we were surprised that they didn't do it as much as we thought they would. Now, in terms of the tag placements, as I mentioned, the tool itself is designed so that the only place the tag can be deployed is on the dorsal fin. And that's because of that pressure plate and the fact that the fin has to be, there's no other way you could physically fit any other body part other than the tail fluke or a peck or something into that guide. So all the tags end up being more or less where we wanted them. You can see there's some variation as to where, in terms of height of the fin. There's also some variation in terms of how close that pin is to the trailing edge of the fin. You can see this individual here that's a little bit further back, this individual here that's further back, and that really is a result of the animal very rapidly reacting to that touch. And so from the time the touch occurred, it's already accelerating away from the tool. And so instead of being flush up against the fin, the back of the fin, there's a bit of a gap there. On those videos I showed, you could see there's a bit of a follow through by the tagger in order to try to minimize that. One thing that, because it's a single pin fin mount rather than multiple pins like the limpet tags, it does mean that there can be some rotation of the tag, some pivoting on here. And I'll show you a photo later that shows that that pivoting can cause the top of the tag to do some damage on the trailing edge of the fin, which was unexpected, but not surprising. Now, this shows the distribution of attachment durations for our limpet tags on small odontocetes. We've deployed I think 121 limpet tags on a combination of bottlenose dolphins, melon-headed whales, pantropical spotted dolphins, pygmy killer whales, and rough-toothed dolphins. The longest median duration for those 5 species was for bottlenose dolphins, about 15 days. And the longest duration overall was 34 days. By comparison, the attachment durations for the fin mount tags so far is dramatically better. The median is 40 days. We're now down to just 3 of the 9 tags continuing to transmit, so that median will stay at 40 days, but the maximum is now 48 days, and depending on how long they'll last. These are, I may have said attachment durations, but these are actually transmission durations. The fin mount tags and the splash tags in particular are known to have lower battery capacity. We have also had at least 2 of the spot tags where the battery has failed and the tags remained attached. Because we've been tagging off of Waianae in an area where there's a lot of tour boats, a lot of people, it's going to be a rare opportunity to get a good series of follow-up photos on animals to be able to assess how long the actual attachment duration may be rather than the transmission duration. Now this just shows the maps of all the movements. Some of them are like 42 days plus or 37 days plus because these maps were created last week and some of the tags were still transmitting subsequently. So there's been some additional movements. All of the animals have spent either all of their time or the majority of their time around Oahu with just some limited movements over to Molokai. National Marine Fisheries Service considers there to be 3 different stocks of bottlenose of spinner dolphins around the main Hawaiian Islands based on genetic analyses. A Kauai Niihau stock, a Hawaii Island stock, and then an Oahu Maui Nui stock. So there's been known that there's been some movements between Oahu and Maui Nui, Molokai, Maui, and so on to the west. But this has given a bit better idea of what the temporal scale of those movements may be. Now, if you look at all the individuals combined, it's clear that they're using the entire island. The one area they're not using here, Kaneohe Bay, there's a barrier reef. It's the only barrier reef in the main Hawaiian Islands that basically encloses Kaneohe Bay, so it's not surprising that spinner dolphins having been moving into that bay. So it gets really interesting when you look at the animations of movements of tagged animals. This particular individual is one of the fast lock tags, and it's color coded, so nighttime black versus daytime in yellow, just a simple sunrise sunset for that. And you can see obviously the individual spending its days in relatively shallow nearshore water and moving into offshore waters at night. And I'll show a couple more animations, but you'll also see in this one that there's these general rules of what the animals do, but then there's also exceptions. So there's at least one case coming up soon where the animal will, in the daytime, in the transition from daytime to night, it won't go offshore right away. It'll spend some time near shore before moving offshore. And this bay it's in there is Makaha. If any of you go to Waianae, I would highly recommend going snorkeling at Makaha. It's a beautiful place, and it's very likely that spinner dolphins may swim by. There's spinners using Makaha almost every day. That's where a lot of our tags were deployed. But you can also see this use of these fine scale features, and some of the analyses that we have planned will look at that in detail. Keep in mind that this tag was transmitting into last month, so we haven't really got to any of that analytical stage yet. So the 2 splash tags that we deployed recorded the first dive behavior data that's available from any sort of tag for spinner dolphins. Kelly Benoit Baird had done some work with hydroacoustics many years ago as part of her PhD work through the University of Hawaii, where she was running transects offshore and using basically an echo sounder to document where in the water column spinners were. But this is the first data that actually documents movements of individuals over time. This particular plot shows the distance between the two splash tagged individuals, basically to show that they're acting independently. So we didn't tag two in the same group and they were traveling together the whole time and doing exactly the same thing. And we have just over 5 days of data from one of the two individuals and almost 10 days of data from the other. Now, daytime dives, not surprisingly, since these are in relatively shallow waters and resting, were relatively shallow for both individuals. Here, the scale is just down to 30 meters. One of the things, though, that we were able to document is sometimes the daytime dive durations were longer than what people would expect, a maximum of 9 minutes. This is particularly important because there are researchers that are using aerial surveys to estimate abundance of spinner dolphins, and they need to be able to estimate what the likelihood of detecting a group on the track line is. And so it was the reason why we set these tags to record depth for any dive of 5 meters or greater. Normally for our limpet tags, we're only looking at much deeper dives. But we really wanted to be able to capture these daytime dive durations and dive depths because it's relevant for any of those future abundance estimation studies. Now, nighttime, by example, here is very, very different. The scale now is down over 300 meters. The maximum dive depth for both individuals exceeded 300 meters. And dive durations were actually relatively similar in terms of maximums, but much longer for the median dive durations. So that's just one example of a couple hours. If you look at it over a much longer period, it really shows the very strong diel pattern in diving behavior. So on the top left is a 24-hour example from one individual, and on the bottom left, that same individual over the entire dive record. Effectively, all of the deep dives were at night, and all the shallow dives, well, during the day were exclusively shallow dives. The two plots on the right-hand side show dive depth by diel pattern, and you can see that during dawn and dusk, there's a lot more variability in dive depth, and that probably reflects that transition from foraging into a resting and socializing period. And dive durations also diel pattern, although not as strong as the dive depth pattern. Now, I mentioned resightings of one individual. This particular tag is the one that stopped on day 6, but this animal was seen on day 36 or 38, and this damage here on the trailing edge of the dorsal fin is caused by that pivoting of the tag. And as I mentioned earlier, we're really lucky that this work happened in an area where there's a lot of human activity where we're going to be able to get these follow-up photos. In most cases, we see animals a year after they've been tagged or 6 months after they've been tagged, and we're not only going to be able to document that long-term healing of these, but also get some idea of the more shorter term. Spinner dolphins, I suspect, of the small odontocetes are probably the most likely to have this kind of trailing edge damage to the fin, and that just reflects their spinning behavior. All species, when they get remores, or not all species, but many species, when they get remores, will leap to try to get rid of the remores. But spinners actually spin, and I think that just puts more force on the tag, more motion on the tag, and more likely to get that kind of damage. Bottlenose dolphins or spotted dolphins, when they do have remores they're trying to get rid of, they will sometimes do some leaps to try to hit that remora against the water. But nothing to the extent that spinner dolphins do. So I wanted to show a couple more animations. This one shows 3 different individuals. They were all tagged on the same day. And this really illustrates some of the variability in daytime and nighttime patterns. Again, it's not just one general trend, but sometimes they are coming in close to shore at night. Like there, for example, the animal comes right in off of Pearl Harbor, that middle one. while others at the exact same time are foraging offshore at night. And I think that it reflects in part the just uh, individual variability, but it also seems to be related, at least to some degree, to the physiographic structure around the island. In some areas there's a very steep drop off. In other areas it's a much more gradual drop off, and some of the near shore nighttime behavior seems to be occurring more in areas where there's a steep drop off. And I have one more animation, I think, to show you. This is, again, two individuals. They were tagged about a week apart, but this shows the time when they have overlapping data. In this case, it just shows one example here of where they joined up, went over to Molokai, and then split apart again. But it illustrates, again, just the diversity of movement patterns. Sample size of 9 is pretty darn good, I think. And we are planning on deploying more of these types of tags off a different island, hopefully off of Lanai in October. And I suspect that each island area in Hawaii, and I should say that movement patterns and habitat use does vary for this species among the main Hawaiian Islands. And I suspect the tag data are going to show the same variability. And actually, I have one more animation here, 3 different individuals again. So that's it for my presentation. If anyone has questions, as long as they're not about false killer whales. Great. Yes. Well, there's mechanism for to release, and it's based on dissimilar metals and corrosion. So the pin is stainless, and the nut on it is aluminum. And when that will happen is unknown at this stage. But when I asked Randy Wells about it, he was thinking, 2 to 3, 4 months kind of thing.
Thank you for the presentation. Is there other place where they use this type of tag? Or
Where they use?
this type of tag?
Well, I should say these single pin fin mount tags have been used extensively by Randy Wells in the Gulf of Mexico on live captured animals. So they've deployed, I'm not sure altogether on bottlenose dolphins. Well, for the Atlantic spotted dolphins, they deployed 8 with this method, but the tags themselves had been deployed. There's a paper by Balmer et al., I think 2012 or 2015, that talks about the advantage of this particular tag type. The more recent work that Randy has done is the first time the tag type had been paired with the tool to deploy them. But the tags have been, on when you've got an animal in hand and or you've captured it and you're tagging it with these single pin fin mount tags, they get very long attachment durations, sort of 100, 150 days.
Yeah, super interesting to see this these results of the movement patterns. Thanks. I was curious, given that these animals you said are in an area where there are a lot of eyes on the water, do you have any sense of whether the spinning reaction was sustained or whether it was an initial reaction to the tagging event, or whether they're continuing to spin to try
On subsequent days,
them?
my suspicion is that they are going to continue to spin on subsequent days to try to shake the tags the same way they do with remoras. I mean, when you're working with spinner dolphins, even these resting spinner dolphins, you'll see spinning behavior happening fairly regularly throughout the group, so when we were out there for 10 days, we deployed 3 tags the first day, and then we deployed the fourth tag on I think day 3, and so on. We were relocating our tagged animals over that 10-day span, and we didn't see any spinning of our tagged animals when we saw them on subsequent days. That said, I think they are, but it's not like when we spotted them again the next day, it's not like they were spinning continuously.
Thanks, Robin. Super cool talk. Also, that you're presenting this after basically a month of this happening is really impressive. I'm curious about the sort of logistics of the tagging, given that you're doing it in shallow waters where there is a lot of human activity. How do you navigate, eyes on you while this is happening? We, with the gray whales that are near shore here, we opt, not to biopsy or suction cup tag whales in certain areas here because
Yep.
we're so wary of eyes on the water and not being able to explain to people what we're doing.
Yeah, for the tour operators, we did a lot of outreach specifically targeted at tour operators. So I contacted all of them. Well, I should say we have good relationships with a couple of the tour operators that are major contributors of photos to our work. But then there's a lot of tour operators who I've never met and are less interested in the science side of things. But contacted them all a couple months ahead of time, saying, "Hey, just to give you a heads up, this is something that's going to be happening." Contacted them all a couple days beforehand. For the tour operators, we also we take out a lot of volunteers. So in the 10 days we were on the water, we took out 27 different individuals as volunteers. Those included people from 3 of the 6 tour operators came out and witnessed tagging. Those people then can be sort of nodes of information sharing within the community. When we were on the water, we were they're all using the same VHF radio channel, and we're telling them what we're doing. And so several of the tour operators witnessed us tagging on several different days. We also did a lot of work on social media over a month or so prior to it. And that was both mentioning that this is what we're going to be doing, but it was also showing them examples, showing people, whoever happens to be on social media, examples of some of the movements of tagged animals that we've tagged in the past of limpet dolphins, limpet tags specifically off of Oahu. So we're really gearing, we posted an animation on bottlenose dolphins and on pilot whales and on spotted dolphins. And we also created a website that showed a photo of one of the Atlantic spotted dolphins with one of these tags, gave if someone wanted to have information on what we're doing and found the website, they could get all the information on the tagging from that. We also contacted all the potential enforcement people on Oahu, so they knew. We fly a yellow research flag with the permit number. So in theory, if enforcement gets a call about a boat approaching dolphins, they can say, well, did the boat have a yellow flag on it? And at least immediately identify that it's a research vessel. That said, you can't reach everyone, of course. There were a couple, one particularly interesting interaction where there's a lifeguard just south of the Waianae Small Boat Harbor that has a bullhorn that is amazingly loud. You could hear every word she said at least a half a mile offshore. And when we were working with a group of spinner dolphins there, she basically got on the bullhorn and said, "Vessel with the spinner dolphins, you must move more than 50 yards away." And she, it's like everyone could hear. It's not like we didn't hear her. I mean, we continued to work with that group. She made some phone calls. So after the end of the day on land, I went and talked to her. We were too far from shore to talk to her, but she had eventually reached state enforcement, and they had told her that we were working under a research permit, and she was okay with it after that. but so that sort of shows you the value of the yellow research flag. We had another woman up at Makaho who was swimming with the dolphins, uh, and um, and we were working with the dolphins. We were probably um, about here to that white van with the swimmers were about that far away. They ended up taking some video footage of us. They were able to look and see the research flag and actually read the numbers, and they Googled yellow flag with those numbers and found our webpage for the project. They were still a bit upset about us. I think that and I, they sent an email and I responded to the email. My feeling is that uh, getting, no matter how much public relations you do, you may reach and may have a general agreement with 70 or 80% of the population that what you're doing is acceptable given the purpose and so on. There's always going to be some people that are not going to be happy with it. And I'm okay with that. I feel it's important to try to do all the outreach possible to make sure that if they want to find information, they can. We were also during the project doing basically a daily or blog on our website with photos of, and also on social media with photos of the tagged dolphins and information, so that one of the things we couldn't be accused of is being secretive or not providing information back to the communities. And yeah, I think I was surprised that I did not get any calls from enforcement. I was surprised. I expected to. There was one case on a Facebook group. It's like an Oahu Dive Facebook group, and someone posted a video of us working with some spinner dolphins, and they said, "Is this the Cascadia Research Collective people? I heard they're out tagging spinner dolphins." So they knew that we are out tagging spinner dolphins, and they posted it, and they got a couple comments, including one from me that said, "Yep, that was us." You know. Yeah, no, it's a good idea. We are doing research.
Okay, so Daniel Palacio says, are there sensors on any of the tags that can measure an index of spinning activity and package it for Argos transmissions, or do you have plans for that?
It's a great question. I don't think that Wildlife Computers tags don't have that capability for these, but it would be a great thing to have. So I think that it's very unlikely that they're going to produce a new tag model just to capture that in any short period of time. But I think it's a great idea.
And Lee Torres asks, do you have any information on individual demographic unit like adult, juvenile, or pregnant that could help explain variation in movements and space use? Perhaps flying a drone over the individual pre or post tagging could help with assignment to a demographic unit.
Yeah, no, that's also a great suggestion, Lee. We know the sex of 3 of the individuals that we tagged for sure because, well, the one that I showed a photo of it spinning, you could actually see that it was a female from the view of the genital area. And we had one with that camera that's on the pole that after tagging, it rolled, and you could see that I think was also female. We tagged one male for sure. Underwater footage, I think, would also be really valuable for males in particular, not to be able to get a good view of the belly, but just to be able to document the post-anal keel that adult male spinners have. I don't think we tagged any adult males, although we tagged at least one subadult based on the dorsal fin. Spinner dolphins as adults are sexually dimorphic with dorsal fin size and shape. But the males are a little bit less likely. I think the adult males are a little bit less likely to bow ride. A lot of the animals we tagged, we classified as subadults. And that makes sense because subadults are more likely to bow ride, I think, in general. You know, we did have a drone on board, and we did have that capability, and I think it's a great idea. It's not something we use simply because of the logistics of all the other things that are going on. You know, there's trade-offs in how you spend your time, and we're either trying to get good follow-up photos after we tag, or in some cases we were trying to tag more individuals after we tag. So.
Okay, and one more question. Bruce Mate says, very nice job. Does the way some tagged animals come together from time to time suggest that they operate quite independently and just happen to overlap, or that this is just one widely ranging population with subgroups?
Yeah, well, it's very interesting, and the people who work off Waianae with spinner dolphins really had this idea prior to this that there were a couple more stable groups of spinner dolphins off of Waianae, and we very quickly disproved that, where you would tag two individuals in the same group and they'd separate a day later and then join up at some point. I think there's certainly a lot of fission fusion. The groups are not stable really in any way. Although obviously mother-calf associations would be for at least a few years, and there's also a possibility of maybe adult-male bonding that could occur that we wouldn't have captured in this. But it's gives the information on the dynamics much more in real time than you get with photo ID, particularly as it relates to the entire island. You know, the photo ID studies that have been done in the past have tended to work off of Waianae for weeks or months on end, and are photo IDing those animals. Also, of the 9 that we tagged, I think only 3 of them were particularly distinctive prior to tagging. Spinner dolphins have a pretty low rate of distinctive individuals. I think it's like 35% or so, which means that using photo ID to look at the dynamics of interactions among individuals is restricted only to older, well-marked individuals. So I think there's as I mentioned earlier, you know, we haven't gotten into any of the detailed analyses. These are just showing some graphics of the data and animations of the data, but it's certainly that dynamics of associations is something that can be done with this data set.
On visit to Hawaii, you can see there's a lot of effort to try to minimize the impact of tourists on these animals, and the way you read gives you this impression that they're going to a bay and spending the whole day there hanging out. But I saw from your animations they were doing a lot of movement during the day. Was that a surprise to you, or?
Well, this is the longest I've ever spent with spinner dolphins. And it's also interesting, the different islands. Well, so the spinner dolphins that were down here were moving around a lot. So there were 3 primary areas where they're resting off Waianae. One right up here, just north of Ko'olina, Pokai Bay, which is right south of the harbor, and then Makaha. And the ones at Makua, tended to be more stable in that area all day long, whereas the ones in the other 2 areas tended to move around a lot more within the day. And off other islands, you know, off Maui and Lanai, spinner dolphins are often moving during the day, you know, between Maui and Lanai, or moving along the entire south shore of Lanai. Off of Kauai, they're moving a lot during the day. And so I think it shows that there's both a lot of variability among islands, but in this case, around the island. You know, what the animals were doing on the south shore, there's been very little photo ID effort on the south shore or anywhere else other than off of Waianae. And so they're often out here. They're often in much deeper water, further from shore during the day. Up here, they were in deeper water, further from shore during the day. You know, there's this perception that spinner dolphins in the research community and elsewhere, that spinner dolphins spend the day in these shallow nearshore areas. And that may be true for the handful of places where people have been studying them, but it's not necessarily true even around the same island. And that makes sense. Those, this area up here is fully exposed to trade winds. So, moving in closer to shore isn't going to be any more protected. And one of the things that we'll do when we get to the analysis stage is try to come up with estimates of proportion of time in different areas and how that varies by depth and distance from shore for those daytime resting areas.
Cool. Great talk, Robin. I guess before I ask my question, just to follow up on that, so have there been an analysis on the individuals that are in the most crowded bays that are exposed to the most, tourists interacting with them? Are they repeatedly coming back to the same bay, or are there some individuals that do that, I guess, rather, or does it seem like they all kind of move around and?
Yeah, so both off of Oahu and off Kona, individuals are definitely from one day to the next are definitely using different resting areas. So it's not like they're using the same resting area every day based on the photo ID. If that answers your question, yeah.
And then another question, with a lot of efforts to move tagging towards with using drones, with suction cup tagging and a lot of efforts right now to even do implantable tags. This seems like it would be very challenging on a lot of different fronts, but I'm just curious, with all the hype around it, if you and your team have had discussions about, what it would take to move operations to the sky and if it even makes sense in this case.
Yeah, I mean, we're involved in one of the projects that's trying to look at drone deployment of limpet tags, and the species that I think is particularly valuable for that type of methodology are ones that you can't get close to by boat. And so, I think the reason my Office of Naval Research is interested in that and is to be able to tag beaked whales, for example, that sometimes you can get close to them, but sometimes you can't. My feeling with this methodology is that we will probably start using the TADpole system for deploying limpet tags on species that bow ride, and I don't see any reason to change that. There's some. I think it's going to improve attachment durations. It's going to minimize risk, and it's also going to allow us to tag individuals or age classes that we otherwise wouldn't be tagging. And so I'll mention false killer whales. I know I said I wasn't going to talk about false killer whales, but juvenile false killer whales regularly bow ride. Adults much less so. We have not targeted juvenile false killer whales for limpet tagging because of the size and thus the increased risk. But I can really see how we would use these types of tags, tadpole deployed tags on juvenile false killer whales. And I showed you those attachment durations for all the species, which I'll go back to because it's just so amazing how well these fin mount tags have worked by comparison. But we get a lot of valuable information from these relatively short attachment durations on these small odontocetes, particularly for species where little or nothing was known about their movements beforehand. But if we can double those median durations or triple those median durations with less risk to the animals, I think that'll be extremely valuable. Some species, like our tag deployments on rough-toothed dolphins, all but one of those are off of Hawai'i, where rough-toothed dolphins like to bow ride. Rough-toothed dolphins off other islands in the main Hawaiian Islands rarely bow ride. So, we're not going to be using these tadpole system fin mount tags with rough-toothed dolphins off of Kona. And so I think going back to your question about drone deployed tags, I don't see any reason why once the system is working, one of the target species for drone deployed limpet tags is Xiphias, which have relatively small dorsifins. The dorsifin of a Xiphias is probably smaller than the dorsal fin of a rough-toothed dolphin. So I don't see any reason why that kind of system couldn't be used eventually with smaller odontocetes as well when those animals are not approachable. I think of striped dolphins, which are almost impossible, at least in the Pacific, to get close to. Some places in the Mediterranean and North Atlantic where you can get close to striped dolphins, but whether or not they would react to a drone is another question. But yeah.
Thank you, Robin. Very good talk. And I was wondering if you have thought or if it's possible maybe to modify the tagging device to take probably a biopsy or a blood sample at the same time of tagging.
Yeah, and actually, if you go back to that original paper, I think it talks about the system potentially collecting a biopsy sample, and that functionality has been taken away. But the coring tool that basically goes through, retracts, and leaves the pin in place. The original one had a couple barbs inside, so that when it retracted, there would be the core of the fin in there. And the engineers at Woods Hole eventually took those barbs out because they were concerned that it was basically slowing it down. This whole thing happens in like 20 milliseconds, but dolphins move so fast that every millisecond counts in this case. So those biopsy samples are not being retained, but it's possible that that could be revisited now that we know the system works most of the time. And I should say there's only 2 of these tools in existence. We had both of them with us in Hawaii. We used one and successfully deployed, I think, 4 tags with it. And then we had a number of tagging attempts where it wasn't successful. And something changed, although we don't know what. It's gone back to the engineers to try to diagnose. And even though it still seemed like it had functionality, it was no longer being successful. So I now feel we're in the beta testing phase of this. So then we switched to the newer tool, and it worked perfectly. But there was nothing other than the fact that it wasn't tagging animals. There was nothing that was obvious diagnostically to say why it wasn't tagging animals. So when you think about it, there's only 2 of them in existence, still in the beta testing phase. It's not going to be a widely used methodology until there's more and until more of these failure points have been identified and corrected. And that's why I say, it's beta testing is part of beta testing is to figure out what isn't going to work, why it isn't going to work.
Okay, well, thank you very much, Robin.
Pleasure.
And if you have any more questions, he'll probably stick around for a few minutes.